Good morning, dear students. You can see my slide. So let us start. Impregnating. Somebody mute yourself. All of you, you mute yourself. So let us start impregnating, coating, peeling and bonding materials. In last lecture, we finished asbestos and today we'll finish solid insulating material. So different materials are used to increase dielectric strength. I told you, suppose impregnation, paper which is on your table, it's a insulating material and you want to increase its dielectric strength. So how you will increase its dielectric strength? Just immerse that paper into the oil, insulating oil. So it will increase dielectric strength because porous materials, or you can say breakdown strength of the paper will increase. So what are different materials which are used for impregnation? Coating, suppose you know paints you are doing. Sometimes materials are painted to avoid moisture absorptions, and then strength will also increase due to the paint coating. So different materials we'll see which are used for coating. Also peeling, peel means peel, it will be peeled, and bond also means the strength of the material will increase. So what are those materials? So these materials are produced from artificial and synthetic organic and organometallic compounds. So metallic compounds are used, but synthetic and organic. They are also produced from vegetable oil. So vegetable oil is a very good insulating materials because it will not conduct. The vegetable oil will not conduct, and as it is a insulating material, it can be used to fill up inside the material. Suppose transform is there, you just pour insulating material in that, so all the parts will get covered. So vegetable oils are also used, or some products which are produced from vegetable oils and petroleum origin, they are used. So these materials are classified as waxes. So you know the wax, natural wax, you know. So synthetic wax is also there. So first class is wax, petroleum and insulating wax. Second is insulating varnishes. You might have observed varnish, a black, just like for making road, or that damper is used. So like that varnish is also looking same. So insulating varnishes we use for impregnation, coating and adhesive materials. Filling compounds will be there, binding and bonding materials will be there. So these are the classes. If you'll see the wax, which is petroleum and insulating wax, it may be natural origin. You know how wax is natural, or it can be man-made also. Wax is soft, you know, it is a very sticky material and it's very soft in nature, but mechanically weak because it's a very soft material, so mechanical strength is less. Natural wax as bee wax have limited applications as insulant. Hence, artificial waxes as paraffins, caseins, and halo wax are used. So these are man-made wax. So you can make depending upon your requirement, and you can use it. It is also classified into two types. Means wax also can be classified into two types. Petroleum wax, it is
Ma'am,
produced as
PPT is not
precipitate.
visible.
PPT is not visible, all of you?
No, ma'am. Yes, ma'am.
Yes,
Not
ma'am. No,
visible.
ma'am. It is not
Yes,
visible,
ma'am.
ma'am.
So
No, ma'am.
No, ma'am.
before saying me in every lecture PPT is not visible, you just go on confirming. Is there anybody who see my PPT?
No, ma'am.
No, ma'am. No,
Then when
ma'am.
you will tell? When you will tell? Hmm? Can you see now?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
Okay. So wax are also classified. Actually, see, this is descriptive topic, so there is no need of PPT also, but still I am making. So types of wax are classified into two categories. Petroleum wax, it is produced as precipitate, resulting from solvent, means that you know the what is meant by precipitations and solvent treatment. of residue during distillation of petroleum. So that will be one class, which is petroleum wax. Second wax is insulating wax. It actually petroleum wax is also used for insulation only. Insulating wax, it is used as an impregnating material for paper and cloth. I will show you what is mean by impregnation, because again and again I am using word, and that is now removed from the syllabus, impregnation treatment. But still I want to show you. So an impregnation material for paper and cloth insulating as a dipping material. Dip means papers will be dipped in that liquid, all I told you. So as directly applied coating on the conductor. So okay, so that is the another type of wax. Now insulating varnishes. Second class is varnish. So these are solution of substances like resins. Today Aarushi will cover resins. So these are solutions of substances like resins, bitumen and dry oils. Again for varnishes also. For varnish also resins is used, bitumen, dry oils are used. It is the solution of resinous material, because resins is used. So it is said that it is solutions of resinous materials in the oils, alcohol or some volatile material, because varnish is volatile. Remember, means if you will take it immediately to the fire, it will catch up. But that varnish will be means you can say wet. But dried varnish will work is a good insulating material. The main applications are impregnations, coating and adhesion. Adhesion means to stick that coat on the material. These materials from solid films on drying, which have low hygroscopy and adheres well to the surface. So I said when that varnish is dry, so drying is also done. That will be heated. Now varnishes are also classified as impregnating varnish. So these are used with porous and hard fibrous insulating like paper. Paper is porous. So which is material which is porous? So impregnating varnish is used for that. Cardboard is also we have seen press board, cardboard, fabric. These increases breakdown voltage and mechanical strength, because varnish increases breakdown voltage and mechanical strength, because that porous will be filled up with good insulating material. When we say porous, it will be filled with air, and air is weak insulating material than varnish. Varnish is a liquid. So liquid insulating material have higher strength than air. And that's the reason why impregnation will increase the dielectric strength. So it will increase with reduction in hygroscopicity, because as pores are removed, there is no chance that it will absorb the water. So it will improve hygroscopicity also. Then coating varnish is another type, means you will not impregnate. Impregnation is a very lengthy procedure. 1 day, 2 days are there. Materials are heated, dipped in the varnish. But coating means just you take the brush and just apply that on the material. So coating varnish, these are from tough waterproof films. So tough water films films are used just like paint on the surface of the object, and special coating varnishes can be directly applied on the metal surface, because you want to insulate that conducting materials. Therefore, you will just coat it on your conductor. So adhesive varnish is third type. So adhesive means it will get stick up. You will not coat by brush, but it will be just like a tape. Suppose you are using tape. You know, you are using tape for the insulation. So like that, adhesive varnishes are also there. These are used to bind solid insulating materials like mica together, or insulating materials to a metal. Suppose you will take two materials. Suppose one sheet you will take of mica and one sheet you will take of paper. So bind it with the adhesive varnish. Okay. Now watch this for the impression. Actually, I used to take students in industry to watch the transformer winding, different insulating materials used in the transformer. Then this I used to take in capacitor industry in the Bhosri, and then varnish impregnation plant they have. Students used to climb up and see inside this everything. But now I will show you virtually. अभी जमाना बदल रहा है, सब कुछ वर्चुअल करना है. What happened to this video?
Welcome to a brief presentation on electrical engineering impregnation systems, brought to you by TechnoExpert. So what is impregnation? Impregnation is simply the process of sealing porous materials with a resin, and is performed in order to improve the function of insulation systems. It is primarily used in the electrical engineering, aviation, and automotive industries. For our purposes, we will be discussing the impregnation process for electrical machines such as motors and generators. But why do we need impregnation systems? Lying at the heart of these electrical machines is the insulation system. Typically, the first and main cause of electrical failure in a motor or generator is due to breakdown of the insulation used for the coils and windings. As the insulation ages, the breakdown voltage of the machine begins to degrade quite substantially. Therefore, ensuring a robust insulation system that can last long enough is vital. The reason for this failure is usually due to the inherently imperfect nature of the material structure, as well as irreversible changes due to the aging process. Physical voids in the insulation material ultimately exist between the wires, leaving it susceptible to external influences, such as moisture. If the gaps are left untreated, the finished products will suffer subpar performance and lessen longevity. These gaps may cause a variety of issues related to temperature, structure, and efficiency. Gaps and voids provide a low-resistant path for electric charges, thus lowering the breakdown voltage of the insulation system. Partial discharges may occur, causing progressive deterioration of insulation materials. This will eventually lead to electrical breakdown, and in high-voltage instances can be very dangerous. Structural stability becomes an issue, as these gaps result in a weak sponge-like construct, which is susceptible to fail under pressure caused by vibration or expansion and contraction. Environmental factors may lead to further degradation of the insulation, especially in humid climates, as the silicone-based mica tape is highly reactive to the water from the moisture in the air. And in addition, untreated insulation results in negatively affected thermal conductivity, worsened thermal endurance, and an increase in the rate in which internal temperature rises. Modern impregnation technology can solve all of these problems. Instead of having to scrap finished products due to the defects causing them to fail during factory tests, installing an impregnation system can be an easy solution to reduce rejection rates to a negligible amount. An impregnation system helps companies by reducing their costs, saving energy, increasing productivity, ensuring product quality, and extending the lifetime of their products. So what methods are available? Well, there are various impregnation methods available, chosen based off of such factors as the voltage of the machines and the cost of the system. For example, many low-voltage manufacturers use hot dipping technology or trickle impregnation. However, for our purposes, we will be discussing a method known as vacuum pressure impregnation, or VPI, which involves the use of a vacuum and pressure, as the name implies, along with a resin instead of the traditional varnish, and is primarily used for high-voltage motors and generators. The vacuum pressure impregnation process consists of several steps. Preheating. First, the part is placed in an oven and preheated in order to evaporate any moisture and improve resin penetration. Dry vacuum. A vacuum is then applied to remove air and any remaining moisture. Filling. The resin is introduced into the chamber from the bottom up and fills in the gaps in the material. Wet vacuum. The vacuum is reduced and kept at this level for a certain amount of time. Pressure. Through the use of dry air, nitrogen, or other gases, pressure is applied to the chamber to further increase penetration. Draining. Finally, the chamber is vented of pressure, the chamber is drained, and the part is removed. Curing. Lastly, the part is placed into an oven to heat up the resin. Even for low-voltage application, VPI is greatly superior to solvent-based varnishes and the conventional dip-and-bake method. Varnishes tend to lose about 50% of the initial volume during baking, leaving voids and air pockets in the windings. However, due to VPI's use of resin under a vacuum instead of varnish, it provides a nearly 100% solid structure, guaranteeing the leak-proof and corrosion-proof requirements of parts and components in critical operations. VPI can be used for AC and DC stators, armatures, and field coils. Where can I find an impregnation solution that's right for me? With TechnoExpert Corporation. We are a major supplier of raw materials, equipment, and relevant engineering services to a wide variety of industries throughout the world. We pride ourselves on our excellent customer service and our ability to respond quickly and efficiently to our clients' specific needs. Expert knowledge and a client-focused culture have made Techno Expert Corporation the industry standard for client satisfaction. Our principal, Meyer Prozesstechnik, is a German-based manufacturer with over 30 years of international experience and knowledge in plant engineering. They specialize in high-quality, highly customizable impregnation systems, including VPI. We offer plants ranging from simple manual impregnation systems to fully automatic state-of-the-art VPI systems with process visualization and data communication. Our systems include both vertical and
Okay, so you have understood what is meant by impregnation and how it is done. Okay, so that part is now removed from syllabus because number of materials are also reduced because we need to cover in 6 lectures, and also we have increased scope of the practicals, not the theoretical things. So third type of material is the peeling compounds. Varnish you have understood, impregnating materials you understood, wax also you have seen. Now peeling compounds, so it will be peeled inside the material. So these are used as for impregnation and peeling in electrical apparatus. So which material will be used for peeling? So bituminous compound and quartz powder, you know. So quartz is also used. Then bonding and binding materials. It is used in electrical apparatus, instruments, industries, also for low capacity electrical machines. Means for low voltage it will be used, not for high voltage. These are in forms of films and tapes. I told you the example of insulating tapes. So for bonding and binding, tapes are used. Now which material is used for bonding? Insulating materials to each other, means to joining and insulating materials. Now let us start with gaseous insulating materials, and then Aarushi will present. Aarushi, are you ready? Aarushi?
Yes, ma'am, I'm ready.
Okay, I will complete gaseous insulating material and then you can start. So now you know gaseous insulating material, air is the biggest insulating material which is available abundantly. So let us see about the gaseous insulating material. So dielectric gases are used as an insulating material and also heat transfer medium. So why it will be used as a heat transfer material? So when you will use air inside any material, or when you use air as a insulating material, suppose transmission line, overhead transmission line, where air is used as a insulation. It's a natural media there, but it is used as a insulating material. So when air is used as a insulating material between the two conductors, it is also giving purpose of cooling also, because air is a coolant, oil is also a coolant. When you use solid insulating material, heat transfer will not be so much, means cooling ability is not there. But when air is there, air will circulate and it will create a cooling effect also. That is also for the oil. Oil will also have cooling effect. So there is another advantage of using air and liquid as compared to the solid. So they are classified as, now how you can use gaseous insulating material, they will be classified as air, nitrogen, hydrogen, then SF6 also it is used, then oxide gases. Oxide gases are carbon dioxide, sulfur dioxides, and SF6 is electronegative gases. So if you see electrical engineering applications, in electrical engineering applications, SF6, sulfur hexafluoride. This gas is very popular in our electrical devices. Why? We will see that. And another class is hydrocarbon gases like methane, ethane, propane, freon, etc. So out of that, I think only air and SF6 is in syllabus. Okay, so be careful about the syllabus while preparing and selecting materials. First, restrict yourself which materials are mentioned in syllabus, and then you can prepare here and there. So air. So you know it is most important of all dielectric gases because it is free gift of nature. There is no money, no cost, and also available in abundantly and also easily available. So due to this popular, it's popular. Its dielectric strength is 3 to 5 kilovolt mm. So see the dielectric strength is also good. It is higher than some solid insulating material. Permittivity of air is about 1 to 1.0054. So permittivity is one that also you know, because permittivity plays important role in storing the charge and using as a dielectric material. Solid insulating materials have higher permittivity. So they will be having dielectric strength. So dielectric strength depends upon permittivity. Dielectric loss angle is practically zero. So this is the most advantage of air. So what is the meaning of dielectric loss angle is zero means tan delta. I told you loss angle, loss factor, dissipation factor means tan delta. And when tan delta is zero means unity power factor. Now you have studied lagging power factor, leading power factor and unity power factor. So unity power factor means loss is zero, loss angle is zero means it is the perfect air insulation is a perfect because loss will be less. It is reliable at low voltage. Why it is reliable at low voltage? Actually, it's not a drawback, it's an advantage because reliability of air dielectric material is good. Why? Because it will work as insulating material means insulating material only. So reliability is good, but at low voltage, not at higher voltage. Because when you go from lower voltage to the higher voltage, you have to switch over to the other insulating material like SF6 and then oil. So air needs no processing because air you will not require any varnishing or no peeling like no processing also, and hence can be used directly because air whatever is available composition in the air you can use it. Its dielectric strength increases linearly with increase in gas pressure. So remember this, when gas pressure is increased, dielectric strength will increase. Why? You have to think it. If gas pressure is increased, number of air molecules will be larger. Suppose you imagine electrode gap is 1 centimeter and you inserted pressure, some pressure air. Then how breakdown will take place? If number of gas molecules are more, the breakdown strength will more means breakdown voltage will increase. Why? That we will discuss when we will complete ionization process. By the time you just go on thinking what might be happening if gas pressure is increased, why dielectric strength goes on increasing. What are the advantages of air? It has low leakage currents. Already I told low leakage current. Leakage current means what? See, we don't want any current to flow through the insulating material. But still always current will be flowing and that current is called as leakage because it is a leakage. But air when it is used, it has low leakage currents. Means leakage currents in air insulating material is low. So it's very beneficial as compared to solid and liquid. So solid liquid has some leakage current, but in air it will be low. We will discuss it why it will be low. We have to discuss all these things in unit number 1. Then it is available naturally and in abundant. It is free of cost. That already I told you. Then what are the disadvantages of air? Air carries dirt. You see in the air, we cannot say what dirt is there, what moisture is there. Humidity is there because humidity will also affect on the breakdown strength of air. Whether liquid moisture is there, which settle parts in winding because when such a air will go in winding, then that moisture will settle in that and it will just create a liquid form also. So that by it will go on reducing its dielectric strength. Then chemicals, acid, alkalis are also there in the air because we don't know what fumes are there from the industries and different pollutions. So that will also damage our insulation. Then oxygen in air is disadvantageous. Why it is disadvantageous? Oxygen in air, it will catch fire. And we are insulating means in our voltage, due to the voltage, insulating materials are used and when voltage will be high, fire chances are there, but it will help the fire. That is drawback of air. And high voltage easily punctures air insulation. So I told you air will not be used at a high voltage because air is not so strong to use it in high voltage. Now you will ask me how the transmission lines are used. The transmission line, even if they are carrying very high voltage, you just see how much spacing they are used. Spacing between two conductors is very large. And if you want to use air in our devices, then your device size will be so bulky if you will use air For transmission line, it's okay. It's used in the atmosphere. There is no space criteria. But in the devices, there is space criteria, then its volume. So that is thing you have to understand. Its dielectric strength increases slowly with increase in distance. So if you will go on increasing the distance between suppose two electrode, then dielectric strength of air will increase. Why? Because that insulating material itself increases. So therefore dielectric strength will increase. Then it has low dielectric strength. Low means as compared to other. Always we have to see these comparisons with the another material. Now what are the uses of air? It is used in plugs. So you know the plug you are using in the wire, you plug in devices. What is the media used in the plug? Air only, because if you will not use some material between the two plug or terminals, it will cause the short circuit. But you are insulating, you don't know, but you are insulating that two plugs with the air. Switches, air circuit breakers. So when you use the switch, night switch, you can just see, then air is used. Circuit breakers also it is used. Then it is used between two conductors of transmission lines. It can be used in different appliances and electronic tubes also. So if you see tubes or lamps also, air is used there. It is used as a coolant in small transformers. So when small transformer, you'll see, I already told you how it will work as coolant. Then consider SF6, the most popular gas used in electrical devices. So it's SF6 means sulfur hexafluoride. It is electronegative gas. So what is the meaning of electronegative gas? It has greater affinity for free electrons. So suppose you are using this SF6 gas in the two electrodes, and when insulating material will starts breakdown means current will start flowing. And you know when current will start flowing, when electrons will start flow. So electron will start flowing from suppose cathode to anode. And in this case, electrons are moving from cathode to anode means current has started moving. But in its journey, when it is electronegative gas, what will happen? The gas will go on capturing the electrons. Suppose one electron is freely moving from cathode to anode. Then this gas will just attract that negative electrons. This electron is negative. So electronegative gas means what? The gas molecule will go on attracting free electrons which is moving, and itself it will attach to the gas molecule. So gas is having affinity for electrons. और तुम्ही मराठीत असं म्हणा की तो इलेक्ट्रॉनना खायला लागतो. खायला लागतो म्हणजे काय? अटॅच करून घेतो, अट्रॅक्ट करून घेतो, स्वतःपासून दूर करून देत नाही, स्वतःला चिटकून घेतो. तो एखादा इलेक्ट्रॉन चाललाय पुढे एनोडकडे, तो लगेच अट्रॅक्ट करतो, त्याला खाऊन टाकतो. So electron attachment process goes on taking place. So free electron will not reach towards the anode. It will just get stuck up with the gas molecule, and therefore electrons will not move easily, means current will not move easily. And this is a very important property why SF6 is popular. Dielectric strength is 2.3 times greater than that of air. So you have to remember SF6 is C. It's a 2.3 times more greater than that of air. So this time you have to remember as a points what is the dielectric strength of any material, and of comparison how many times it is, double, thrice, 4 times. So this can be a 1 point. It is colorless, odorless and non-inflammable. So this is also very important property. SF6 is colorless, you can't identify, like air only. It is odorless also, no smell is there, and non-inflammable is there. Because when you are using gas in some electric devices, and if it is poisonous, then what will happen when operating persons will go there, and they will just get affected due to the smelling or due to its color. Due to its color also eye problems may start, and due to smelling, if it is smelling something, due to the smelling some health hazards will be there in the body. So it's not desirable when we are using some materials in the devices. So property of SF6 as a colorless, odorless and non-inflammable also has made it very popular. It is one of the heaviest known as gases. So heaviest, weight is large. I can say that is the drawback. So it has low solubility in water. So it will not soluble in water. It can be liquefied after compression. Why compression is required? Because when you will use gas at high pressure, dielectric strength will increase. Pressure increases, dielectric strength will increase. Therefore, compressions are used. But it can liquid, means gas will convert into liquid if you will compress too much. It has better cooling characteristics than air and nitrogen. So air and nitrogen in that SF6 is more advantageous. And it is outstanding arc quenching property. This is the most important property why SF6 is used in the devices. Arc quenching, see, whenever we see high voltage is there, suppose circuit breaker is there or switch, circuit breaker is like switch, you will use it to make a circuit on and off, and if it is very high voltage, arc will create. You might have observed in your home also. Sometimes when switch on the buttons, arc you can see. That is at 230 in your home. But when you will see very high voltage, that arc is very strong. And you know what is the problem with arc? To create the arc, very high voltage is required. But once that arc is created, it will continue at low voltage also. Suppose the arc is stuck and you reduce the voltage, still arc will be there. It will not extinguish. And extinguishing arc is a very tedious process. So वो जो misfire होता है switching से, उसको cool करने के लिए, सीज करने के लिए बहुत difficulty रहती है. तो वो arc quenching कहलाता है. So arc quenching property is very good. So SF6 will quench the arc. Whenever arc will create due to the switching, you are using SF6 in the suppose devices which is switching and arc is stuck, but that SF6 property will squeeze that, cool that due to its electronegativity. What are the applications of SF6? It is used in high voltage switchgear. So switchgear means switching devices. Okay. Cables, voltage stabilizer, X-rays apparatus. It can be used in transformer and microwave equipment. It makes possible to design circuit breakers with a small dimensions. So it will be used in circuit breaker with small dimensions because dielectric strength is very good. You use air circuit breaker and you use SF6 circuit breaker. So strength is 2.35 times greater. So your device size will be very small if you will use SF6. It is used for GIS. So you remember word GIS. So gas insulated substation. So in the substation, whole substation, SF6 will be used, not air. Generally air is used, but if you will see very high voltage substations, it will be insulated with the SF6 gas. So gas insulated, it is in Rasta pit. We would have seen in normal condition. So gas insulated substations or gas insulated cables. Means in cables also you will use that SF6 to insulate different conducting parts of the cables. Now liquid insulating material that we'll see in next lecture. Now I am giving time to Aarushi. Aarushi?
Yes, ma'am.
You can share. You are ready now?
Oh, yes, ma'am.
Okay. I will stop. Now you can continue.
Ma'am, is my presentation visible?
Yes.
Okay. So good morning, everyone. I have chosen the topic of resins for my activity 13. So let's begin. So resins are both solid and liquid, but liquid they're highly viscous. That means it's highly thick, and they have certain properties such as they harden on heat, and they can be used as setting agents, or when in contact with light, again they harden. And there are two types of resins basically, from resins derived from plants and synthetically derived resins. And they can be used for 3D printing. The major use of resins is as glue, because they hold the two fibers together. And resins can be used as resins are converted into polymers through the process of curing. So let's read what's written. Resin material can include both solid and highly viscous materials, but commonly refers to liquids which harden based on heat, setting agents, or light. Typically, modified or synthetic resins are used for manufacturing. They are produced from natural components with additives or consist of artificial polymers. It is used for 3D printing. Now, first resins have been found in nature, in plants, bugs, or trees. Amber or shellac are some of the examples of natural resins. These natural resins used in some products, but usually they are flammable and fusible. May appear soluble in liquids, which makes them not suitable for some applications. And again, the curing process that I told you about. Okay, types of resins. Now, resins are divided into two types: thermoplasts and thermosets. Thermoplasts are basically the ones that can be melted, sorry, and they harden once cooled. Within the molecule chain of such resins, there are extremely strong bonds between molecules. So they are they're strongly bound together, and then they harden uh, when they're cooled. And whereas thermosets, they undergo a non-reversible reaction in which the resulting in the hard end product. It is determined by the by the process called polymerization or cross-linking. Okay, so thermosets are converted into polymers, whereas thermoplasts, they harden, and hence they are used um, in, I mean, the examples of thermosets are epoxy, vinyl ester, etc. And they are used as insulating materials. Whereas thermosets are used as polymers. They are used in ABS and different other uses. Okay, the chemical properties of resins are that they, on heating, they soften and finally melt. They're insoluble in water, which is somewhat of a disadvantage, because when insoluble in water, it I will read further how is that a disadvantage. And yes, they're insoluble in spirit, but they completely dissolve in alcohol. Spirit is different from alcohol and chloroform, and hence resins dissolve in alcohol, but not in spirit. Chemically, resins are complex mixtures of resin acid and resin alcohol, resin phenols, esters, and chemically inert compounds known as resins. So basically, resins are made of acids, of alcohols, of phenol, esters, sorry, and some other compounds such as resins. So now these resins define whether it's a resin or not. These resins are the main functional group. And again, I told you the examples of resins and some temperature at which they melt, and their properties, such as ABS. It melts at 100-degree, and it has glossy finishing, and it has good shock resistance. Epoxy, great physical and chemical properties, easy to cast with. And nylon, great wear resistance, and it melts at 140. So please take this table down. I think it's important. Okay, now here are some examples of the epoxy resin. Epoxy resin is the most commonly used resin, by the way. It is used in a lot of different things, and we'll see the uses further. Okay, now uses. As I told you, it's used in 3D printing. Resins are a family of photopolymers that consist of photoinitiator and different monomers. These materials react under UV light, daylight, or laser beam energy that can change that changes their state from liquid to solid structure. So in 3D printing, you have a photo initiator, okay, and these materials, as in resin and all, they react under UV light or laser beam, and they change their state from liquid to solid, and hence you get the printed 3D printed model. The main use, I told you, the main use of resins is glue, because it transfers the stress between fibers and it holds them together from outside factors. Now, next, they're using low volume production, props in medical industry and more. Yes, resins are used in low volume production and in medical industries because it requires molds which are filled with liquid resins and hardens inside polymerizing. Some resins are easy to use and compatible with silicone or DIY molds. Yeah, you might have seen some videos on YouTube and all about some jewelry made of resins, or some household this thing, what do you call them, some gift parts that are made from resins. So resins, they harden easily, and that property is used here because of their hardening property. And yeah, so now they're used in adhesives, paints, and coats. They're used as decoration. This is what I was saying. Because of their hardening property, they're used in decorations and electronic components and replacements for metal parts, gears, pipes, and tubes, intricate models and parts. They're used in jewelry as well and medical devices, and consumer goods, boards, car and ABS, because it's very important for the braking system to work properly. Hence, hence it holds, resin holds the braking part and the command which is given. I mean, can't explain properly. Yeah. So here's a short video of resins used as resistors. I mean, as insulators. Sorry.
Electrolube epoxy resins are available in a variety of pack sizes, pre-measured, ready to use. In this example video, we're using a 250-gram resin pack, which has a mix ratio of 2.5 to 1. But the method is the same for all pack sizes. To begin the mixing process, remove the end cap and gently pull the pack apart so that the clip pops open. This allows the two parts of the resin pack to combine. Using the removed plastic clip, push all of Part B into the Part A section and begin mixing by moving the resin around in the bag with your hands. To ensure the two parts mix thoroughly, use the clip to push the resin together, ensuring as little as possible sticks to the pack sides. Continue mixing and repeat this process for around 2 to 4 minutes until the resin is fully mixed. The resin is then ready to... The corner of the pack can be cut to act as a simple dispenser.
Now in this video you will see different types of epoxy resins and their uses in different cases.
Hi, I'm Steve from Fiberglass. Today we're going to discuss epoxy resins in general and the epoxy resins we carry on fiberglass.com. There are three main types of resin used to make composite parts and molds: polyester, vinyl and epoxy. We carry resins of each type, and as you might expect, each type offers benefits and drawbacks that must be considered when selecting your resin. There are many advantages of epoxy compared to other resin systems. Epoxy resins are typically the highest strength resins in the industry. They offer the strongest bond between the resin and reinforcement and allow for construction of the lightest parts and most durable molds. Epoxy resins are typically chosen for their excellent mechanical properties and dimensional stability. When properly cured, they offer good chemical and heat resistance and extremely low shrinkage. Since epoxy resins bond to dissimilar materials and previously cured materials, they are a great option for repairs. Most epoxy resins can be post-cured with heat to improve their strength, service temperature, and dimensional stability. Because heat causes post-curing, parts should be cured or post-cured at a temperature that matches or exceeds their expected maximum service temperature prior to being put in service. If an epoxy part or mold is subject to a service temperature higher than it was cured, it can distort or warp. Epoxy is the best resin type to use with carbon fiber and Kevlar reinforcements. These high-strength fibers are very difficult to bond to. The bonding of epoxy resins offer a strength that cannot be matched with polyester or vinyl ester resins. Epoxy resin also forms the strongest bonds to fiberglass fabrics and most sandwich core materials. This all adds up to epoxy resin being the primary choice for structural applications. Epoxy resins do have their drawbacks. These include being more expensive than polyester or vinyl ester resins and typically having longer cure times. Epoxy resins will also turn yellow and oxidize when exposed to UV light, including sunlight. Due to their mix ratios and the precision required when measuring, they are typically considered more difficult to work with than polyester or vinyl ester resins. Last, they also are more temperamental when it comes to moisture and temperature variations during mixing and application. If you are working in a high humidity environment, you will probably have problems getting your epoxy resin to cure. Common uses for epoxy resins include aerospace and aircraft applications, automotive and racing, military and defense applications, marine, as well as sporting applications including snowboards, skis, or hockey sticks. Epoxy resins can be used for most general purpose hand layups, mold applications, and almost any composite part. There are many types of epoxy resins in the market and an even wider range of products simply referred to as epoxy. Fiberglass epoxy resins are intended to be used for laminating composites, and they are all first quality. With first quality resins, you don't have to worry about batch-to-batch variations like you would with lower quality resins. With our resins, the color, viscosity, laminating, and strength properties will be consistent batch to batch. We have a full line of epoxy resins at Fiberglass, each with specific strengths. Our System 1000 is an excellent general purpose epoxy for non-structural parts and repairs. It is typically used in the automotive and marine industries. System 2000 epoxy resin is a high-strength structural epoxy for room temperature applications. It offers the highest strength possible for a room temp epoxy and is commonly used in the aerospace, automotive, racing, and marine industries. System 3000 high temp epoxy resin is formulated for high temperature composite part applications. It has a maximum temperature rating of 309 degrees Fahrenheit and is useful for underhood automotive applications and other high temp products. System 3300 is a high temp tooling epoxy. It is specifically designed for the production of long-lasting high-temp molds that you can use when using pre-preg fabrics or fabricating with high-temp epoxy resins. To learn more about each of these resins, including their physical attributes and more specific uses, be sure to check out their product pages and the videos on our website. You can check out our complete epoxy lineup when you visit the epoxy category at fiberglass.com. If you found this video helpful, and if you'd like to watch more, be sure to subscribe to our channel and like this video.
So now advantages and disadvantages of resins. Advantages: precision, large variety of resins with different properties. Now we've seen in the previous video that epoxy resin itself has different variety inside. Just a second. Just a second. There's something wrong. Wait. Yeah. Ma'am, is my screen visible?
Yes, yes.
Yeah. Yeah. So just now we've seen that epoxy resins have different variety in itself with different uses and different properties. So hence a large variety of resins with different properties, a wide range of applications. They can be used from medical to jewelry purposes. They can be used, they have a very large scale of applications, and they can be food safe. Yes, they are used as packaging for food. You've seen those plastic I don't know what plastic bags that are used for carrying food. Over there also resins are used for that plastic manufacture, nylon. As we've seen, nylon is also in the previous slide. Just let me show you. Wait. Yes, see, nylon. It's also used as a resin. So packaging for food materials. That's also a major use. Just a second. Yeah. And they can be easily colored, dyed, mixed with metal powders or fluorescent pigments, and they're easy to work with, and they hardened resins can be machined. So hardened resins are very strong, and hence they can be machined. Next. Some disadvantages are some resins are toxic, yes, and it's very hazardous for health, and fast polymerization reactions requires being quick. Yes, polymer. See, as I told you that the resins further convert into polymers through the process of curing, where polymerization of single link happens, one link polymerization. So that has to be really fast, and it requires special storing. And because some resins are sensitive to moisture, temperature, and light, as in the video we've seen that some resins they react in the presence of UV light or even sunlight. Hence, they're very sensitive to light, moisture, and temperature. Okay. Casting resins need components accuracy. Yes, when you cast resins, you have to be very accurate. That's for everything. Casting requires accuracy, and low volume casting may require much handwork, which makes its net cost high. Yes. So yeah, that's it. Ma'am, that's it.
Yes, yes. So Arushi, very good, well done, and really it's appreciating that Arushi started activity number 13 very immediately, and she is opener now. She has initiated. So I request all other students to do activity before 15th of August because we have lot of work to do. Only one thing I would like to request that you please concentrate on all the internal activities because there are chances this term will go like this only and all your marks may be with only internal work. So don't neglect internal work, lectures, then assignments. No practical hours are also started because if situation continues, then we have to give marks like this only. So on what basis we can give you the marks? Since how many days I am telling you, those who have not attended lectures, attend video lectures, mark there, but not a single student is doing that way. So you are very careless. Many students uploaded assignment second yesterday night. I slept at 12:30. I just checked 2-3 assignments. They are very good. I told Adarsh also, Arushi is also I have seen, but Arushi just I think did a shortcut in that assignment. Then few assignments are really good. You are taking hard efforts, but only few students are doing like this. I request all other students to be regular, go on submitting in time. Now assignment number 3 you had to work. So what I will tell you for assignment number 3, first just take all the materials, 5 materials, and do memory map. So while doing memory map, you can focus on what can be characteristics, common characteristics of the material, like tan delta, permittivity, color, odor, weight, temperature rise limit, like this. See, my this can book, I already told, I have my own book of material science, and I have already collected good notes from all other material science books. And my book is a combination, at least for this insulating material, I can tell you, of all other material science books. So I'm not giving what's the purpose behind that. I scanned that book chapter, insulating material, that the PDF is ready. Actually, I wanted to post you also, but when I will post that, what will happen? You will just go on simply referring that and will start creating memory map. I don't want you to do that way. You just open the treasure hunt. You know, internet is very much a treasure hunt. म्हणजे एक खजिना आहे, खजिना. जर तुम्ही वेबसाईटवर बसलात तर तुम्हाला इतकं काही काही छान छान हातात पडेल ना, की तुम्ही चक्रावून जाल आणि इंटरेस्ट क्रिएट होईल. सो माय इंटरेस्ट इज दॅट ओपन दॅट ट्रेजर हंट which is at the moment of one finger click, and just enter in the treasure hunt and just get lost in the information knowledge that I want to make you open that, use that, create that, learn that. So you will get tan delta of all materials. Suppose 5 material you selected, you find out. Suppose you have selected asbestos, and in my notes tan delta is not there. I will tell you. I have not done like that. But now internet is available to you. So if you have collected a few general points, then you can say tan delta of asbestos, color of asbestos. Like that, you first generate the common points and try to get all values. Suppose temperature rise. So that will be really good collection of notes for your 5 materials. That way I want you to open the treasure hunt, just refer that. Then you will come to know how much is available and how you can use that online resources. That is also one skill, because Aarushi, when she prepared for resin, Aarushi, can you tell me how much time you took for resin collection? Aarushi?
Ma'am, it took like around 2 to 3 hours because I had to search on the net for different articles, and then I read it, and then what was relevant I had to put that.
Then see students, miss for 10-15 minutes she took 2-3 hours. I am also spending lot of time, you know, because now one first thing PPT I had to prepare, picture I have to add, videos I had to add. Really it takes lot of time for one lecture. So I think that way also you will generate very good learning resources that will be help for all of us, for the future students also. That is just hand in hand moving. So that will be also good learning resource creation. Now Aarushi has done resin. I will not prepare now that resin PPT. I can use her PPT. So like that it will be also collection together. That will be additional benefit side by side. Another thing is that now she spoke so confidently. She spoke not 10 minutes, but she spoke more than that. So 10 minutes is expected, not less than 10 minutes. Okay. So that way your communication skill, your boldness, actually in the online presentation, there is no burden. So no people is sitting in front of you. You can just see the screen is there. That's all. So this will be a good beginning of coming ahead and speaking something. And now you are preparing PPT also. Aarushi, how many times you had prepared PPT earlier?
Sorry, ma'am, your voice was not
Your
audible.
PPT, how many times earlier you had made PPT? Means पहले कितने बार PPT किया था?
Edit. I edited this PPT around 2 to 3 times. Adding something and then
No, not for resin. For another presentation, कितनी बार PPT किया था पहले?
मैम किया है, काफी बार किया है हम लोगों ने.
किया है. तो
किया है.
अभी स्किल कौन सा इम्प्रूवमेंट हुआ है?
मैम बिना कुछ प्रिपेयर करे से बोलने में भी अगर इजीली खुद ही बोलना है सामने तो बोलने के लिए इजी रहता है अभी।
नहीं 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 नहीं, पीपीटी प्रेजेंटेशन का स्किल कौन सा इम्प्रूवमेंट हो गया? आई एम आस्किंग दैट वे।
हाँ मैम वो बनाते बनाते अपने आप समझ में आने लग जाता है कुछ टाइम बाद कि कहाँ पे कैसे करना है, कौन सी स्लाइड कहाँ
No,
कौन सी स्लाइड आगे आएगी।
whether you think that your skill is enhanced, PPT making
Yes,
skill
ma'am.
is enhanced.
Definitely.
So that is what I wanted through the activity number 13. Your ICT tool uses skill should be enhanced. So please consider that if you know earlier PPT presentation, you add some one or two controls in that, another one two skills in that. So like that I want to say you. So students, now we will discuss in tomorrow's lecture. Tell me who will present tomorrow. Every lecture we can plan like this 10 minutes. So it will be a good implementation of time also. And tomorrow who will tell? All group monitors have to monitor all these. Start working without any instructions. You are leaders now. See, Arushi is monitor, she is demonstrating. So all others you demonstrate and do your monitoring job for activity number 13 for all our activities. So I am expecting something from ahead for tomorrow's presentation, and tomorrow we will complete this liquid insulating material, and tomorrow will be last lecture on this unit. And the part insulating materials used in capacitor, cables, transformer. Students who have taken that topic, come ahead immediately and try to finish up to Friday. If you are not selected topic, you select that topic, insulating materials used in different devices. So that way Friday our unit will be completed. Start preparing for the unit test on the 3rd of August. Okay, have a good day. Any doubt is there? Somebody want to ask? कोणाला डाऊट आहे का?